welcome participants once again to the NPTEL MOOC module on exploring health data. We are on the verge of the last week where we target ourselves to the understanding of healthcare data and their programming, especially how to evaluate some of the health policies. In this regard, we have already discussed a lecture on clarifying policy evaluation and different techniques that are largely used in the previous lecture. In this lecture, we will be emphasizing on what is called propensity score matching, and this is one of the design which is largely used both in experimental case as well as in observational case studies. So, there are number of decisions to be taken while going for propensity score matching, that is in short called PSM. I am just going to introduce about you all. This is on how what are the genesis of PSM. We often study the effects of a condition on developing a problem on the effect of an intervention. So, intervention that is called treatment or public policy on overcoming a problem. Like suppose we say any policy, let it be Poshan Abhiyan, what has impacted the people due to any sort of intervention, maybe insurance scheme, whether that has actually undermined the cost of expenditure of the persons or not. So, you can do field experiment, or you can also go through the database, those are available through the observational studies, and can identify a number of gaps within it and can suggest whether some of the policies are effective or not. So, we have to take two similar groups in this case, that is except one group is receiving an intervention or treatment in order to see the impact of an intervention. But if the two groups are not similar before treatment and the outcome is affected by underlying characteristics, then problems of selection bias occurs. So, like if you do not equalize the starting two set of groups, where in one set of group you are having certain treatment, whereas you are not having treatment, but these group by definitions are not same, by assumption they are not same, or by starting point they are not same. So, how do you know that your treatment has actually caused certain differences, or your policy intervention has caused certain differences? That is why if you do not go with similar two groups, so that may lead to selection bias. Propensity score matching is used when a group of subjects receive a treatment and we would like to compare their outcomes with the outcomes of a control group. While using observational data, we often face the problem of omitted variable bias or selection bias. So, either by selection we are omitting variables, or there are some bias, or by the variables are omitted, so by some reason that may create biasness in the model. PSM is a method of addressing the selection bias and moving towards more causal estimates. It is not like the cross sectional or least square method or the normal regression technique. This is rather give you certain causal relationship in the estimation. PSM is introduced by Rosenbaum and Robin in 1983. This is also called quasi experimental method. RCT is usually called the experimental design or method, but this is quite quasi, not exactly tapping the impact of one with another one. There is no clear understanding of the cause and effect relationship. In this method, the researcher uses statistical techniques to construct an artificial control group by matching each treated unit with a non-treated unit of similar characteristics. So, first of all, an artificial control group is created. So, what are the reasons, what are the logic behind artificial the control group is not clearly defined, and there should be the non treated group should have also the similar characteristics as the treated group. So, the treated and non treated group, the assumption, since by assumption we say they are similar, so anyone could be considered as the control group. Okay. And that is why we are saying, any arbitrary one we are just speaking of to define this as the control group is in fact called artificial control group. The researcher can use these matches to estimate the impact of an intervention, and it is useful it is one of the useful methods for estimating the impact of a program or intervention. PSM is used for impact evaluation when it is not ethically or logically feasible to randomize. In reality, as we are going to discuss about randomized control trial as well in our next class, we where randomization is really difficult. There are lots of possibilities of arbitration, lots of possibility of relationship, so of the set of data that is being adopted. So, if wherever you have certain doubt with the randomization, this is one of the plausible method, one of the best method to be applied. That is why PSM is widely applied. PSM is used for impact evaluation in because of these logical reasonings. PSM seeks to mimic randomization to overcome issue of selection bias that plague non-experimental method. So, this considered to be randomized because there is no difference between the two groups. That is how we can avoid the selection bias. There are different steps involved in propensity score analysis. Those steps are called propensity score estimation, matching quality evaluation, and outcome analysis after matching. Once the matching result has come, we need to have the comparison as well. Let us talk about the assumptions of this PSM. The assumptions are like, first one is called conditional independence assumption. What does this mean? For random experiment, the outcomes are independent of treatment, whereas in case of observational studies, the outcomes are independent of treatment, conditional on the X. So, when you are giving a certain treatment in the experimental model, experimental design, your outcomes are independent of treatment. Whatever the outcome you are expected to derive are in fact independent. I mean, your outcomes are independent of the treatment that is given. So, treatment that is being injected is not creating any any sort of biasness to your outcome. So, that does not mean the like any policy intervention is made in two areas. So, the policy intervention does not have a purpose of just motivating one area just to show the result, just to show the outcome. So, that assumption has to be considered in the experimentation of PSM design. Similarly, in observational studies where surveys are conducted, it is conditional on the X. Those X, that is the control variables, whatever were taken, those should not be also should be also independent of the kind of treatment that is taken. Okay. So, in the case of experimental design, we know that the model is like y0, y1, these are the outcome in two categories given the extent of treatment. The treatment is a binary variable that determines if the observation has the treatment or not. Y is the outcome and then y is equal to y naught. If it is the base output, that means there was no treatment. So, this is called actually no treatment, and if it is the new output that is due to the treatment. So, treatment is considered to be 1 here, and here treatment is 0. In case of observational studies, we are conditioning here with conditioning here with the control variables. Those treatments are subject to the control variables, but those are independent also of the way treatments were assigned. We need treatment assignment that ignores the outcome. This is what in the bottom line to be emphasized. The treatment variable needs to be exogenous. This is what is very essential. It has to be exogenous. Some other assumptions are also emphasized, like unconfoundedness assumptions. This says that conditional independence of the control group outcome and treatment. Okay. So, basically it says that conditional independence of the control group outcome and the treatment. So, there should be also also independentness between the control group. Basically in the next one which we have already said. So, this is how where independent of the condition of the control groups. Okay. So, these are actually control groups are also sometimes referred as confounded groups. So, the assumption is that there should be unconfoundedness in the treatment approach. Weaker assumption than the conditional independent assumption. So, basically unconfoundedness is basically the one of the weaker assumption than that of the conditional independent assumption. Another assumption is related to matching or overlap assumption. Matching is discussed as for each value of x there are both treated and control observations. For each treated observation there is a match control observation with similar the control values. Okay. Then another one is called balancing condition assumption should have been also fulfilled. Assignment to treatment condition is independent of the x that we have been saying, x characteristics given the same propensity score. So, given the propensity score, these treatment conditions should always be independent of the x. The balancing condition should be also testable. The balancing condition that has been followed in the model should have been testable. That is also the assumption. Then comes the challenges of this particular technique that is called differences in outcome between the treated and untreated may be the consequence of confounding variables and not the treatment. So, the challenge is that though we are saying the treatment has resulted certain differences in the outcome, but it may be due to the confounding variables. The other confounding or the where the treatment is not given on the cases though we have been saying several times, but the variables may be some control variables are there which are none other than the treatment variables. Those might have also caused the differences in outcome. That is one of the challenges in the PSM method. Data set may include subgroups for which the treatment effects should not be calculated because the subgroup may not be eligible for the treatment. So, the subgroup is also important. All the treatment groups should not be carried on average. There might be subgroup that should be separated. Actually, this is very difficult in PSM approach to separate it out. Though a subgroup may be eligible for both treatment, there may not be enough data for a comparison without extrapolation. Okay. So, let us come for the discussion of implementation of PSM, where we implement and how should we proceed. Now, we need to first get the data. The data must identify which units are treated and untreated, and should all characteristics relevant to treatment participation and outcome. Then we need to second step is to estimate propensity score through discrete choice model. Usually this is followed logistic or probit, okay, or some heteroscedasticity based logit model is also implied. So, discrete choice model where logit or probability is considered for analysis. In this case the function should include all the relevant covariates related to treatment participation and outcome. The covariates should be baseline characteristics that are not affected by the treatment. Okay. The covariates that we have been trying to refer should be actually the baseline characteristics that are not affected by the treatment. So, treatment every time we have said that should be completely independent. Okay. So, using too many covariates to compute the propensity score may result in an exacerbated lack of common support, while using too few may violate the unconfoundedness assumption. So, confoundedness and unconfounded assumption that we have already discussed. So, if you are including too less what covariates or the variables other than the treatment variables. If you are taking too few, then the unconfoundedness assumption, that is how the confounding variables should be independent to that of the treatment, is very difficult to understand. If there are too many, then there might be a lack of support from the confounding variables. So, there might be some problems, we need to take a note on this particular regard. So, too many and too few, though there is no parameter, though extreme values defined how many it should be. So, we cannot have decision just based on our experimentation, we can derive the circumference of these limits. Coming to next step of implementation is to restrict sample to common support. This ensures that units with the same covariates values have a positive probability of being both treated and non-treated. Choose and implement a matching algorithm to match untreated units to treated units. Fifth one is on estimate the impact of intervention with mass sample and calculate standard errors accordingly. The average difference in outcomes between treated with their matched untreated control units is the estimated impact of the intervention. Basically, once you calculate the average difference in the outcome, okay, between the treated one as compared to the unmatched but almost with the similar characteristics, while we make the difference, the estimated impact or the value is nothing but is called the impact of those interventions through PSM. Let us come to the understanding of the numerical values which we usually go through. It is called AT and ATET. Those are also called treatment effects. One is estimated at the population level, one is estimated at the core treated sample level. Okay. So, when we are discussing about our entire population, while we are discussing about PSM, those entire population, the treatment average treatment effect we calculate, we can compare between the control group and that of the treatment group, that is what is called AT. Whereas, within the treatment group of or the sampled population where intervention is made, we can compare their implication in the interventions. Okay. So, let us understand this numerically. I will also experiment with the data, with the technique, and I am quite sure you will enjoy working with it, and there are so many other experimentation that you can easily do it with this basic understanding. We are not going into the depth of or the complete applications of PSM, because there are so many approaches followed by different authors. So, just a guidelines we are giving or the baseline indicators or estimation we are explaining, rest you can experiment and find it out. Coming to the average treatment effect, in short called ATE, it is the difference between the outcome of treated and non-treated observations, that is basically the change between y1 and y0. This is what we already said. So, y1 is the treatment group and y0 is the control group or non-treatment group. So, that AT is all about estimated value of that change. It is y1 given the control variables where treatment is given minus the expected value of y0 given x where no treatment is given. So, AT is in fact going to give you a choice about random experiment and it can be biased in case of observational studies if the treated and control observations are not similar. This is what we have been emphasizing several times. AT is good choice for random experiment. It can be biased in case of observational studies if and only if treated and control observations are not similar. So, the basic structure of this AT is that there should be independentness between treated and control observations, similarly treated as compared to the confounding variables. So, in both the cases, if this is not similar, then it might be problematic. Otherwise, AT is a very good choice for random experiments. Now, we are coming to the explanation of ATET. ATET is basically average treatment effect on the treated group. Within the treated group, we wanted to find out the change, change due to the treatment. It is the difference between the outcomes of the treated and outcomes of the treated observations if they had not been treated. So, basically when we think of some treatment, think of treatment of certain intervention, they start with no treatment actually. So, no treatment and after treatment, that does not mean they are the control group. Control groups are completely separated. The same treatment group, what really happened when we give treatment to them from the starting point, that is basically called the sample, the final sample where we are targeted for the treatment. So, the treatment group is actually compared between these two time period, from their starting till the final outcome. Why we are trying to estimate? Because we wanted to understand whether the treatment group is actually different than that of the control group, and or in the population sample how the result looks like, and in this particular treatment group, within the treatment group how it looks like. We can have a clear comparison for better understanding. So, ATET is basically change in the treatment, change in the value of a program, given the fact that we are trying to estimate for the treatment group only where D is equal to 1. So, this is basically differentiating these as compared to this, but the difference is that in both the case it is equal to 1. But in this case it is outcome 1 and this is outcome 0. So, without treatment to those treated group before outcome and after outcome. So, when we do that we get the ATET impacts. So, some matching algorithms are also made. One is called nearest neighbor matching, then caliper and radius matching, then stratification and interval matching, then kernel and local linear method, then another is called weighting method or algorithm. So, those are also done. We are just giving certain ideas of each of the component here. So, nearest neighbor matching is also in short called NN matching. The individuals from the comparison group is chosen as a matching partner for a treated individual that is closest in terms of propensity score. When like in the command itself, we will also show how whether it is choosing 1:1 or 1:2 or 3 matching. So, whether we are matching with the nearest neighbor or not, that is basically discussed with the NN matching approach. Another is called caliper and radius matching. NN matching faces the risk of bad matches. If the closest neighborhood or neighbor, that is far away, if there is no close value or close neighbor for the matching, then basically it is going to give you bad results or bad matching. In that case, caliper and radius matching is more applied. This can be avoided by imposing a tolerance level on the maximum propensity score distance. When there is a distance between the closest neighbor, in that case you can take a tolerance level that will be helpful for matching. That was suggested by caliper. Dehejia and Waba suggest a variant of caliper matching which is called radius matching. The basic idea of this variant is to use not only the nearest neighbor within each caliper, but all of the comparison members within the caliper. So, even in some studies we suggest that the caliper value should be less than 0.6 and number of samples that is taken should not be less than 200 to run the PSM method. Those aspects we are not emphasizing much, that you can explore in your studies. Next one is called stratification matching. The idea of stratification matching is to have partition of the common support of the propensity score into a set of intervals. They are called strata, and to calculate the impact within each interval by taking the mean difference in outcomes between treated and control observations. The next one is called kernel matching and local linear. kernel matching and local linear matching are non-parametric matching estimators. Okay. There are since they are actually having no parameters estimated, so only comparison is made. It uses weighted averages of all individuals in the control group to construct the counterfactual outcomes. Last one is called weighting on propensity score. Imbens to 2004 notes that propensity score can also be used as weights to obtain a balanced sample of treated and untreated individuals. So, the sample that we have been discussing may be on similar through the propensity score, those can be balanced out. Okay. How one should select a specific matching algorithms, that is also important. Clearly, asymptotically all PSM estimators should yield the same results, because with growing sample size they all become closer to comparing only exact matches as suggested by Smith 2000 paper. In small samples, the choice of the matching algorithm can be important. Okay, choice of matching algorithm is more important, where in case of large sample that is not so important. The performance of different matching estimators varies case by case and depends largely on the data structure at hand we have. For example, if there are only few control observations, it makes no sense to match without replacement. Okay. Whereas, if there are a lot of comparable untreated individuals, it might be worth using more than one nearest neighboring. Okay. Pragmatically, it seems sensible to try a number of approaches, so that we can find out the robustness of the method. Now, we are going to discuss about our practical approach of understanding the values of PSM, how to interpret it. We will use a sample data set. The sample data set is taken from the Stata data set, Stata defined data set, that you can also download. The link we have already given over here. The data set we are also keeping on the portal, you can easily get it. So, let us open the Stata over here, and now on the screen we are going to open the data set. So, we are going to open the folder, the practical data set. This is PSM. Yes, we have opened this data which we have shown to you. Now, we are going to run one thing that is going to be very useful for all of you is this. I am just going to give you some result over here. Like first of all, there are two approaches we will follow. Let us go by the first approach. Then we will come back to through click based approach we can do it, then this kind of result we are going to find, and then we will interpret, and finally we will come up with the command. Okay. So, let us go by this approach first. So, I am just going to open this on the screen. So, we will go by go to the statistics, then treatment effects, then we will click on the continuous outcome, then on the propensity score matching. From here we will take the data to estimate. First of all, here we will understand I will just go to the data first. So, here we will show it couple of things. So, we are going to show it. The data set included information about infant or mother father characteristics from singleton birth in Pennsylvania between 1989 to 1991. The original data set included nearly 5 lakh births. The Stata example data set includes 4642 births. The treatment here we are considering mother smoking status during pregnancy, what this has caused, the impact on the birth weight of our newborn infant. So, that would be basically our outcome variable. Then treatment independent variables are basically the covariates here for us are mother's marital status. These are also called control variables. Mother's marital status, mother's age, mother's marital status, mother's age, mother's education, these three: mother's marital status, mother's age, and mother's education. And another variable we are considering whether the mothers have first baby or not. Okay. So, regarding baby, then mother's age, education, then marital status. So, these four we are going to use it for our calculation. So, it is here on the screen. So, we will once again go to the point. So, we will outcome variable, as I already mentioned, it is our birth weight of the baby. Then treatment variable is our smoking status of the mother, okay, the pregnant women. And so, four variables we are going to consider covariate, that is married, whether mother is married, okay, or then age, then education, then another one is on that is called whether the mother is or have had already a baby with them. So, with these four, with number of matches per observation, and it is matching with other values. So, if you select by one only at this moment and we wanted to find out the result. So, it is here with OK, we get the result on the screen. So, this is going to give us couple of interesting interpretations. Now, the birth weight we wanted to find out, birth weight of the baby. Now, our treatment is like whether the smoking habits or smoking during pregnancy has impacted baby's weight or not. Now, we have seen that we can see here that it is actually impacting negatively. So, score here, the coefficient is going the score the value by certain fall as 203 gram fall in the baby's weight is negatively, and it is significantly related. And the method it is considered as logit method, logit, okay, logit based on the distribution of the data. By default you generally take logit, okay, but we can change when you know the distribution, we can change it to probability as well. Now, it has actually the model is significant, and the birth weight of the baby is actually drastically reduced by 203 grams, okay, due to smoking habit. All right. So, that is important and we have already discussed. Now, I will clarify some other aspects, like this is what we have guided. You have to go to statistics menu, then accordingly you can choose and give the entries. Very important is our outcome variables, then treatment variables, then treatment independent. The Stata calls as treatment independent, or for us we said control variable, these are also called treatment independence. So, these values should be independent to the treatment values, treatment variables. Okay, then with the summation we will get the result like this. Here the AT is average treatment effect, okay, average treatment effect, and treatment effect in population. We are actually comparing the population rate control with that of the treatment group. The groups are actually different and they are independent. You can also use average treatment effect on treated menu instead of average treated effect in population. So, the interpretation, as I already said, it will be baby's weight will be reduced by 203.97 gram. Okay, this is what is explained as compared to the baby who are not the mother who are not smoking. Okay. So, you can also take the note of number of observations. It usually number of observations should be higher in PSM method. So, the same command which I have just shown you can just take a note. It is in fact highlighted here. The command is T effects, P effects, not effect, T effects, PS match, propensity score match by birth weight. Birth weight is our our outcome variable, and by its first variable is the treatment one, then rest are is your control variables, or called treatment independent variables. Okay. So, that is important. That is the same one. If you just feed it into the command window, you will also get the result correctly. Now, this is on the population. We have already clarified the difference between population as compared to the treated group. You can also find out the result with the treated group as well within the group. that is called T effects PS match. Okay, T effects PS match. In this case, the difference rest are same. The difference is that we need to specify which one we are going to find the result. If we are specifying within a comma followed by ATT, average treatment effect on the treated group. If you try to find out, then we have to specify this. With this, we can just show it over here as well. The same command we are just taking it once again and just carrying forward with comma ATT. Okay. Now this is going to give us the result. So within the sample where the treatment has been applied, we are comparing the same group before the treatment and after the treatment. We found that those mothers who didn't smoke as compared to smoke, those who have already those who are smoking during their pregnancy, their birth weight actually reduced. So now in the treatment group itself, the impact is higher than that of the control group. We are not giving the logic behind the difference at this moment, but it depends on your experimentation and you will find out the result accordingly. Just to compare which one is more impactful for your understanding, and I am sure you can find out more results on this, and that will be going to give you better evaluation of large scale data, okay, and you will have better publication out of it. Any sort of queries if you have, don't hesitate and come back to us in writing on the query portal of NPTEL. We will be happy to deal with all those things very carefully. Our team is quite active. Okay, so thank you very much. Expecting your participation in the next class. Thank you.